Okay, so moving on to section 2.2, I'm doing question 93, and this asks us to draw two equations and draw the region bound by the curves and then find the volume where the region is rotated around the x-axis. So the two equations that we have for this is y equals 4 minus x squared and y equals 2 minus x. So the first thing I'm going to do is I'm going to draw the graph, and then I'm going to set the two equations equal to each other so we can find what the x values are for our bounds for integrating. And for this, we would use the equation v equals pi times the integral over the region that we are about to find. And then inside the integral, it would be the first equation squared, f of x squared minus g of x squared dx. So let me set that up and then I will show you. So I drew out the graph and set up the equation. I hope you can see this a little bit better. I'm sorry about that glare. But pretty much this is the graph, and as you can see, this is the region that we're calculating the volume for in the first region. And to set up that equation, I just set 4 minus x squared equals 2 minus x, and then I just put it all on one side, got x squared minus x minus 2, and if you, I guess, like reverse FOIL that, like you get x minus 2 times x plus 1 equals 0, and that gives us our two x values or our bounds for our integral, which are x equals 2 and x equals negative 1. Next thing we do is we use that volume formula, the washer method, I believe. One second. Yes, so we can use the washer method to find this volume, and how I set that up is v equals pi over the integral negative 1 to 2, and the equation is 4 minus x squared minus 2 minus x squared, and then dx. And now I'm going to try to simplify this and then get that simplified equation integrated so I can just plug in my negative 1 and 2 and then find the volume. So I finished up question 5. I'm going to try to get the lighting on this. Sorry about that. So I think you can kind of see it better there, but the first thing I did was I set that volume equation equal to pi integrating over negative 1 to 2, and then again the equation is 4 minus x squared minus 2 minus x squared dx. Next thing I did was I just distributed the squares within, so I got 16 plus x to the 4th minus 8x squared minus 4 plus x squared minus 4x. And then when you simplify that down, you get pi integral over negative 1 to 2. Inside, it's x to the 4th minus 9x squared plus 4x plus 12 dx. And then I just integrated, and what I got was x to the 5th over 5 minus 3x cubed plus 2x squared plus 12x, and that's times pi and over the range negative 1 to 2. Next thing to do was plug in 2 and then subtract whatever you get with that by plugging in negative 1 to that same integrated equation. So what that looks like is I got 2 to the 5th over 5 minus 3 times 2 cubed plus 2 times 2 squared plus 24, and that's when you plug in 2, and then minus when you plug in negative 1. And what happens when you plug in negative 1 is you get 1/5, and then minus 3 minus 2 plus 12. And then when you simplify all of that down, you get 33 over 5 plus 15, and then that's times pi, which simplifies down to 108 pi over 5 cubic units, and that is the volume of the area between these two cross sections.